properties of logarithms to simplify an expression, algorithmic expression. So remember, the first thing you have to do when working with logarithmic expressions is to apply the power property. So in this example, I have a bunch of logarithms subtracting each other, and some of them have numbers multiplying the logarithms, meaning I have to use the power property to simplify them first. So this, and also condensing or simplifying a logarithmic expression means to condense everything into a single logarithm, okay? So this is logarithm base 10 of x to the power of 4 minus logarithm base 10 of z minus logarithm base 10 of y squared. Now I can start applying the quotient properties. I have two logarithms subtracting here, so this is simplified as logarithm base 10 of x squared, x to the power of 4 over z minus logarithm base 10 of y squared. So again, I have a difference of logarithms. That means that I have to apply the quotient property. So this is logarithm base 10 of x4 over z over y squared. Why did I do this instead of doing logarithm base 10 of x to the power of 4 over z over y squared? Because I'm tired of doing sandwich laws, and we need to start learning that every negative logarithm is going to go into the denominator and every positive logarithm or argument is going to go into the numerator. So notice that I'm left with a single logarithm that doesn't have any number multiplying outside, and everything is inside the argument. So that's how we know we are done condensing or simplifying an expression. Now here, I have a bunch of logarithms, and notice that this logarithm is being multiplied by a 3/2, and this one is being multiplied by a 1/2. So I'm going to rewrite this as logarithm base 9 of 11 plus 3/2, so you can see what I was talking about, plus 1/2 logarithm base 9 of 3. This is the same as logarithm base 9, 11, plus I'm going to use the power property to simplify this. So this is logarithm base 9 of 10 to the power of 3/2 plus logarithm base 9 of 3 to the power of 1/2. Now all my logarithms are left with no coefficient multiplying them, so I can use the product property. That means that all these are going to go logarithm base 9 of 11 times 10 to the power of 3/2. That was the condensation of these two, plus logarithm base 9 of 3 to the power of 1/2. And then to finish simplifying, this is logarithm base 9 of 11 times 10 to the power of 3/2 times 3 to the power of 1/2. I don't need to solve this. All I need is to condense this entire expression into a single logarithm where everything is inside the argument. The end. This one. This is logarithm base 7 of w to the power of 4 plus logarithm base 7 of w to the power of 1/3. Why 1/3? Because this logarithm is being multiplied by 1/3. The same goes with this one. So this is plus logarithm base 7 of v to the power of 1/3. Now my logarithms don't have any number multiplying outside, so I can start using the product property. So this is logarithm base 7 of W4 times u to the power of 1/3 plus logarithm base 7 of b to the power of 1/3. And this can be simplified again with the product property as logarithm base 7 of W4 u to the power of 1/3 times b to the power of 1/3. Again, no numbers outside my logarithm. The logarithm is, we have a single logarithm and everything is inside the argument. Next one, as usual, I'm going to apply the power property first. Logarithm base 6 of x to the power of 3 plus logarithm base 6 of z to the power of 3 minus logarithm base 6 to the y to the power of 12. I'm going to apply the product property first to the quotient property to these two, because why not? This is logarithm base 6 of 6z to the power of 3 over y to the power of 12 plus the existing logarithm. And this is logarithm base 6 of x cubed z to the power of 3 y squared. Single logarithm, everything is inside the argument. Next one. Again, I'm going to apply the power property first because all these logarithms have a number multiplying outside. So this is logarithm base 7 of x to the power of 6 plus logarithm base 7 of y to the power of 24 plus logarithm base 7 of z to the power of 6. All these logarithms are adding, meaning we can condense this as a logarithm where all the arguments are multiplying each other, so I can start working faster. And that's how I condense when I start to understand things. Next one, I have two logarithms that are positive and one negative. Remember, the negative logarithm is going to be in the denominator and the positive ones are going to be in the numerator. So first, power property, logarithm base 6 of c to the power of 20 plus logarithm base 6 of a to the power of 20 plus minus logarithm base 6 of b to the power of 5. These two logarithms are positive, meaning that the arguments are going to be multiplying each other in the numerator, and this is negative, meaning that its argument is going to be in the denominator, dividing. Last one. First, apply the power property. Logarithm base 9 of x to the power of 18 minus logarithm base 9 of y to the power of 3 minus logarithm base 9 of the power of z to the power of 3. Again, all the positive logarithms are going to be, its arguments are going to be in the numerator multiplying each other, and all the negative logarithms, their arguments are going to be in the denominator multiplying each other. So that is how we condense algebraic logarithmic expressions.